We had talked about some things getting us up through just the beginning of the starting to have a deep discussion about what's going on in the AI space. And we'll continue that tonight. Starting with this slide here, we're in the research thing, if you guys remember. We will not do politics at all. We'll do industry, and we'll do just a little bit in safety. But these are the main chapters of it. And I'm just going to launch into this. So this is an interesting one, I thought, where they talk about the capacity of these models. And they say that models have this, I don't know where they came up with this magic number for GPT models, but they, go previous, yeah, 3.6 bits per parameter. I don't know exactly where they came up with that, but that's what they're saying it does. They have a ceiling here, it says on this point, and that defines their ability to memorize. There's an upper limit on that. And I'm really kind of surprised that there is an upper limit on that it's so clearly defined. I would assume that based on the data, based on how you fed the model and things like that, it would know more about, specific parts of its data that it's shared with. So I don't fully understand this. Has anybody else dealt with this? Sounds sort of wrong to me.
Well, for most models that we train, if you train computer vision model, an LLM, um, some fully connected network to predict something small, early on, of course, it's initialized random. Early on, we see it starting to do a little bit better on the training set, and it typically is in this memorization phase. So it's not learning broad patterns; it's just doing better on individual examples, and there's no real generalization ability. And so if you early stop it during this phase, and you give it, test set examples, generally speaking, it'll do like hardly any better than random chance. It's really
Got it.
bad, right? Um, Maybe even worse sometimes than random chance because it's just trying to figure out the training set. And so this is basically the phenomenon that they're saying is when do we start seeing the training curve shift and do we see validation loss like moving better? And if you do this for different size models, you can plot them and then you can sort of see. And then if you plot them, this is where you can see this sort of 3.6 bits per parameter
Okay.
is sort of like defining, right, where the line that all the points lie on.
Okay. All righty. Well, let's move on from that. And then let's talk a little bit about some of these models that they're going on. They did quite a bit on the new models coming out of China in this particular, this year's thing, which is absolutely no surprise, right? It should be no surprise to this group that is going on. I also, and I'll get ahead of myself a little bit, saw somewhere where, Jensen Wang just said something like, well, China can spin up a new data center in like 3 weeks or something like that, whereas the US takes like years to do that, a large data center. They have extra electrical capacity. There are a series of rules they have to follow, much more streamlined, right, on a government-sponsored project and things like that. So I thought this is kind of interesting that the Chinese, and this is kind of a recurring thing throughout this, that the Chinese AI is moving up quite quickly in terms of being able to come out with newer models and things like that, even though they have problems with like getting the latest NVIDIA accelerators and things like that. So it's an interesting thing to see. The yellow stuff are just my highlights in here, so you can take that for what it is here. Yeah, that, now this Moonshot AI ranks #1 on certain of these text models. So that was kind of cool. Okay, and they call it the New Silk Road. Okay, if anybody remembers your history from China, that was the big thing, right? Was to go over to China, trade silks, trade goods for silk, which was very expensive in Europe at the time, and that was what the opening of China for trade was. Let's see. And they are, as they said, looking at open source models, and they are kind of setting the place. They are talking about Quinn, as it says, perhaps, as it moves ahead of things like that. And I think this center diagram here is kind of interesting here, where you had people, using primarily U.S. models until about, September-ish of this year, September, August of this year, and then they're downloading a lot more of the Chinese models. So that's something to be said. And then the ELO rankings, the Chinese models are also leading the way, not by huge amounts, but leading the way against other models. So found that kind of interesting too. Questions, comments? Okay.
Just a quick comment. If the Chinese models are leading the downloads, that means that Meta's Llama is no longer leading the downloads. Just sort of mathematically, only one person can lead. So I'm not so sure. I'm not sure. I don't think this is by any means like a death knell, but there have been a lot of papers published by the Meta Superintelligence Group in the last few months.
Mm-hmm.
And there are some really interesting ones in there, but overall, I have felt like the quality of those papers was markedly lower than what we're used to seeing. So I don't know if it's threats of layoffs, so people were just like, I got to publish in case, I get laid off.
I was going to ask you if you thought it was a publish or perish type deal.
Yeah. So, well, and not even publish or perish, but like, not like it would save your job, but like you might not be able to publish if you get laid off before you publish. So I don't know, but it could be the beginning of a downward trend for Meta.
It's been a while since Meta had an open source model besides that for Maverick. Some people think that they might go proprietary, and that would make sense, right? Because they haven't been keeping up with everything else.
The problem with proprietaries, until Meta has their own cloud, they don't make money off of proprietary models. So, most of the money that they take in, they would end up just giving to whoever's providing them the GPUs. So that's not a very profitable path for them.
Yeah.
So anyway, I don't think we need to spend a lot of time.
Yeah.
Jerry, I had a question on the last sentence of this slide.
Okay.
Where they talk about Meta fumbling in part by betting on MOE.
Mm-hmm.
But is it MOE, at least the DeepSeek stuff is all using MOE, I thought that was, I don't know about Quinn.
I don't know the answer to that. Yeah, I kind of get where you're going, Roger, with this. Isn't it kind of leading edge technology?
Yeah, MOE I thought was,
I was under the same MOE. I was under the same impression. However, maybe these guys have a different view on it.
There's exceptions, but what you see is like the really big hundreds of billion parameter models that are hosted by Qwen, hosted by DeepSeek, that are state of the art in quality. Those are MOE models, but they're small ones in terms of the open weight downloads. Most of those are dense models.
So they could be talking about the latter group that you mentioned then.
Right. So they're talking about community downloads. And so, I've talked a lot about how MOE does not help you if you have a PC with one GPU. You still need to load all those experts. You're not using all of them, but it doesn't necessarily help you with GPU memory.
Okay.
Yeah, that makes sense. I still don't understand why they're slamming Meta for MOE, but not Qwen, for instance. But
because Qwen's small models are dense, they're not MOE.
Oh, they're not. Okay, so it's DeepSeek.
Their big models are MOE, but the small ones aren't.
Oh, whereas Metas are MOE for all sizes. Then is that what you're saying?
Right. So you'll see like DeepSeek 3.2, 670 billion parameters, like whatever, you know, 30, 50 billion, whatever active. But then the small model, you'll see like Quen, whatever. It's just, Quen 7B, whatever. There's no MLB.
Gotcha. And then Llama didn't distinguish that way. The small ones are also MOE then. Is that what this is saying?
Yeah, which doesn't make sense to me.
Yeah. Yeah. Gotcha.
Okay.
Also, there's a very recent news, much after this paper was written. This is from Bloomberg. I just put the link on the chat. That Meta is pivoting away from open source models. So it's really just the Chinese model that are likely to be open source going forward.
Yeah, I've also read a couple of articles, either a code name or something, they're calling it avocado.
Avocado, right.
So basically, what has happened inside Meta, just reading from the outside, is that the whole Fair Lab, Lacun has left. They brought in Scale AI, the CEO of Scale AI. So I think, from what I'm reading, it has completely changed inside. Everything has changed inside Meta, and this new model, Avocado, is supposed to be a closed source. I don't know if what they're going to do with the weights and everything, but that's what came out. And I think today there was some news about them building a image and video model called Mango or something. So there's definitely a shift, and many of the FAIR people have left, and so it's less of a researchy place now than I guess trying to make some money or something. Yeah.
Yeah. I think when I went through this document, that's one of the things I got. It's like, okay, you guys have had too much time mucking around in the lab. We burnt too much money and things like that. We now have to produce real product and monetize it. We're moving to every engineering project I've ever been on has been like that, right? You start with, hey, I got this cool idea, you work on it, things like that. And then at some point you have to move to, okay, how are we going to make money off this effort if we're going to give you a team and spin it up and, blah, blah, blah. And I think we're moving towards that fairly rapidly in some of these things. Anyway, I'm going to move on slide. Okay. This is more on, they say developers are using this, but once again, is this just because it's open source and available easily in China and things like that? Quen alone counts for greater than 40% of new model derivatives. Is that only in China? I don't know. Or are people building off it? They say that the Chinese models got a lot smarter and come in all shapes and sizes. But I don't think they go into the details about that. Okay, let's move to the research side of the house here. And you see that they are moving, they say, to a permissive licensing and steering towards an open weight type thing, with ByteDance having their thing, Quen, ZI.ai are leading the charge, blah, blah, blah. You can read that as well as I can. And then they have some little, I guess, hierarchical diagrams for their models and things like that. So like the ByteDance Verl, which I think is a vertical model. I'm trying to remember exactly what that is. Things like that. And then the OpenRLHF is the simple model they have, which is kind of interesting that they spend, I don't know, I wouldn't have expected them to spend the resources on this, but what do I know?
Yeah, most of them right now are Apache 2, MIT modified, which means if you get to like over 100 million users, you can't use it, like i.e. their competitors. So you'll typically see for the top models, those two licenses is fully open source is Apache 2 and MIT. And then the modified ones will have a section that said, this is the only modification. If you become huge, we don't want you using the model.
Gotcha.
Which was Llama. That's what Llama had that stipulation in too.
Okay, thanks, Kevin. All right, moving on. So the question is, was this a year of good video generation? So we're going to kind of leave those Chinese models behind. And let me stop that. So we did sort of see this year, a lot of good models that are doing some really cool video things. I'm not familiar with GDM Genie 3. I kind of remember Genie 2, but not all that much. And it looks like some of these things are doing pretty cool stuff, like, change the waters, spawn objects with weather, spawn objects with persistence, and things like that. I'm not familiar at all with Odyssey. Is anybody else familiar with it? Okay. But as you read through this, if you see GDM, I was like, who the hell's GDM? And I went, oh, wait, Genie 3, that's Google. So I put that there as more of a reminder for me that Genie 3 is the new Google one that they were showing at Google I/O this year. But it looks like this is starting to become more of a thing, and I think we see these will be moneymakers in my humble opinion. These video models more than a lot of the other things out there, because it is attractive to business people to do things that are very expensive for them. Advertising is a hugely, hugely expensive thing for businesses. And if they can work with an AI-based agency that can cut their costs, in fractions and things like that. If you go on to, any sort of video sharing site, you see early things of that, right? We see people going into the HOA office and getting bombed by a big old red balloon or something like that, and sucked into it or something like that. So you're seeing that sort of stuff sort of happen. And that is only going to go, especially in the commercial space, I suspect, a lot, because commercials are very, very expensive to shoot live. I don't think anybody shoots live anymore. But back when I was working with commercial producers, just the setups alone, I worked with a company that rented video equipments for commercials and movies and things like that. And we'd look at their invoices, and their invoices would be like $40,000 for a month for, cameras, lights, lithium. It's not lithium. It sounds like lithium, but it's a big ass balloon that just gives you this really wonderful even light for outside and things like that. But, it would just be amazing how much these people are spending on this stuff. So I imagine their business is not quite as good as it once was 25 years ago. Anyway.
So I have a question about these
Yeah,
models.
Jen.
It seems like there's sort of these video and image models. There's like these text models, which also do a little bit of images.
Mm-hmm.
And I think the voice models are different. How do you all see that kind of separating out?
I'm kind of wondering if some of those things, like the voice models and things like that, if you think about professional, shooting a movie, a real world movie, you still do have sound stages and things like that. So they're produced separately from that. So I would not be surprised at that level of production that they still stay separate, because you want people rehearsing in a sound stage. Similarly, if you were generating the voice, you'd want it to be very, very clean, nothing in the background, nothing interfering with anything else. So you need to be able, you can segment that off. In terms of, but regular stuff, let's think TV commercials and things like that, the high volume stuff. I cannot see, I do see that more going to the AI space, because advertising is expensive as hell. And now you're on all these platforms, right? Streaming platforms and things like that. And the budget's just not there the way it was 25, 30 years ago.
Mm-hmm.
That's just my 2 cents. So, but somebody else, please chime in.
To me, it seems like there's going to be some computational advantage to keeping them separate. I'm trying to imagine one big model generating both. But on the other hand, it does seem like there's kind of I don't know, nonverbal parts that would go into, for instance, a voice generation where, you know, almost to feed a video into it to get the soundtrack out type of thing. So yeah, I hadn't thought about it before, but I can see a lot of value to, you know, more than just text in. There's a lot more to express than just the words.
Yeah,
Yeah,
yeah. I mean, I was also thinking in terms of like, is like the architecture and the data that they use to train these things and those kind of things as well, and maybe even the embeddings that they use that that would kind of force them to separate these modes into their own different models.
Yeah.
yeah. That's it.
But then
But
again, if they can combine, you can co-embed image and text.
Right,
You know, why couldn't you co-embed image and soundtrack?
right.
yeah,
Yeah,
and
that's my question is like why exactly are they? Because on the one hand, they don't want to add all these modes. They want to have one model that conquers them all. But on the other hand, they are dividing it.
Yeah.
Yeah.
do they care about the modes, or do they just want one tool that they can use that may have, multiple models running underneath? You know what I mean?
Yeah. Yeah. I
I
mean,
think we're looking at it as machine learning or AI engineers, right? We have a different viewpoint than perhaps a advertising director would. If the
right.
advertising director, right, he doesn't give a crap on what we have to do to make the car sound cool and jump the Grand Canyon or whatever we need it to do, right?
Right.
They
No,
just need to.
yeah, but my question was more about like, like ChatGPT and Sora,
Hmm.
even today's thing with Facebook with Mango and
Yeah.
Avocado, and Nano Banana and, Gemini. So why do they have separate things is what's the real driver is what I was wondering. Anyway,
Hmm.
yeah, I don't want to derail this too much.
Okay. Yeah, I don't think any of us know what's going on inside some of these large companies and things like that with any level of detail. So, okay, let's move on then. But as I said, have a little background in some of this stuff and what's going on. So I was kind of interested here, just how fast these things have come along here. From 360 to now. I don't remember if this one tells you, but now you're doing 1080p or higher resolution and things like that, producing videos, and not just 20 seconds. You're doing 2-3 minute segments and things like that on videos. And then this training substrates on sim to real robotics is kind of interesting. I assume that's if you were going to put like a human skin a robot, make it a human actor or something like that. That's what you would need to do so that they move, you're beyond the, what is that called? When we know it's a robot and not,
Uncanny Valley.
uncanny valley. Thank you, Roger. To get it past the uncanny valley type thing. Because, even today, if you watch, I don't know how many of you guys go up to YouTube, but if you go up to YouTube, a high number of those little 60-second videos and things like that are now AI generated. If you go up there and take a look, but you can still pick them out. And I'm betting in a year or maybe less, you will not be able to pick out reality from generated one. They're just going to be that good. And that has, a lot of things from if you want to track it back to money, because everything's money, that tells you that if you're producing these videos for commercial use or for, commercials and things like that, you can cut out a ton of costs. So will 2026, 2027 be the time that most of our media at a certain level is generated? Maybe. I don't know. Okay. Let's see here. Yeah, now they have ones that are doing predicting object interaction in future frames. So they have like two objects moving along or something like that, and then they say, "Oh, well, these things should hit." And if you think about it from spatial physics sort of things, like the two balls on a billiard table type thing, you should be able to do the predictions and things and how they should work, and how this ball hitting another one puts spin on it, and it causes some sort of physics change and things like that. And they're using Minecraft because Minecraft is a standard sort of thing, and they talk about this. I don't play Minecraft, so I really didn't fully understand that. I should have called my youngest daughter, because she works for a video company, and she can just, oh yeah, that's great because they do this and this and this, but it's 16 bits, so it's crap, and it just kind of goes right above my head. Anyway, so those are some interesting things I think that is happening, is that we're seeing these video worlds. This is first line here where it says trains a video world model that can predict object interaction in future frames. So like if two balls hit, it knows how they're going to move apart, and continues to generate them appropriately and things like that. Or if we then drop something into frame and it interacts with those objects, what the end object should be. And so that uncanny valley, once again, I think sort of shrinks down. So I found that interesting. And the Chinese, it looks like, are doing very well in this here. I'm not familiar with any of these products here. Tencent's Huyan Video, 13 billion, sounds pretty small. But it supposedly does some of these things, like deals with, all these weights and things like that. And it's open source. So we could play with it at some time as our little group here. Open Sora, they say, achieves commercial level quality from $200,000 training run. $200,000, depending upon how long it is and what it is, might be very, very cheap, or it might be expensive. And then I'm not familiar with this Kling at all. The one thing I did notice is most of these, though, seem to be at the 1080 realm, where some of the other ones we talked about early can go beyond it. I don't know if they're going to 4K, but they're doing 2K and things like that video, which is probably for a lot of usage differentiable from a 4K, because a lot of people don't have 4K TVs and things.
So at least judging from Reddit threads, I see that Nano Banana is kind of overtaken Sora in video generation. That's the newest release from Google. I mean, I haven't played with them. I can see why many of these things are not open source. They're very, very time consuming to play with. I'd rather have a large company put resources behind it and generate it. But it's interesting to see Google with Gemini and Nano Banana kind of competing head on with open.
Yeah. Now, Google has always had this nano series of models, right? That they're smaller, they're cheaper typically to use, and less powerful.
No, Jerry. Nano Banana is not that. Actually, it's just their code name for video generating tool. It's nothing tiny about it.
Oh, okay. That's what I guess I was going to ask the question, because there historically has always been the
that's just
nano.
their cute name for video generating AI.
Okay. Well, it does collide with their older naming nomenclature. I don't know if they, did that purposely or whatever, because they had if you're familiar with like their cloud stuff, right? They have various tiers that they move up, and of course the pricing goes up and up and up as you move up too. So that's what I was kind of alluding to. No. Yeah, it sounds like I was incorrect in that. Thanks for correcting me, Srini. Okay.
I'm curious. Sorry, Jerry, back on that one. I don't think we've covered diffusion transformers in this meetup. Has anybody been exposed to that?
I'm not familiar with them.
I haven't seen, or yeah, I mean, it depends. It depends on what exactly one means. I think the version that I'm familiar with is like an attempt at like a diffusion-based language model, which I presume is not the same thing because that would be not a video generation model.
Right, right.
Yeah,
Now I'm gonna make note of it. That might be an interesting paper
yeah,
in the future.
Yeah, I did watch a very interesting video from my favorite YouTuber, Three Blue, One Brown, on
Oh,
how
okay. Uh-huh.
video generation tools work from text. So he has a very interesting video there. So that's the extent of my knowledge.
Yeah. I will point out that he is not a machine learning AI guy. He's a mathematician. He's very brilliant, though, and an excellent teacher. And I'm sure if
Yes,
he
indeed.
did that.
Yeah, that's absolutely right, Jerry. That's why I like his videos.
Yeah, yeah. He doesn't assume that, you're into this or something like that. He goes from, okay, you've heard of this and this, and then he scales up pretty quickly, and he does a really good job. He's what's his name? Grant? Is it Grant? I think it's Grant something.
Don't
I don't
know.
remember. But
Yeah.
going back to Roger, your original question,
Uh-huh.
remember like the early image diffusion models, like Dolly,
Yep.
you have this math that says we have a forward process of adding noise, and we're going to train a neural network uh, to try to predict the denoising process. Okay, so the first diffusion models had UNets as the network architecture to predict this backward process. But it's still a diffusion model, no matter what architecture you use to predict the backward process. And so quickly, what people did was they replaced the UNet with just a stack of transformers. So
Okay.
shape of it very similar to an LLM, but the input and output data that it's being trained on is predicting the denoising process instead of predicting next tokens or something like that.
Gotcha.
So
Was there any kind of residual, the UNet style where it's at different resolutions? Is that maybe that's an independent dimension, independent kind of axis of design?
yeah, I think the early first step is you just swap in like a GPT-2 kind of a thing, right?
Gotcha.
And then it can attend how it um, it's got patches to reduce the context size, but otherwise, then it's just kind of like attention.
Gotcha.
I don't know. I don't remember if there are particularly like some kind of like Swin architectures or something that were specifically designed. But if you imagine just like BERT, you have the same number of tokens out as you have tokens in. And that's similar to a UNet where you have the same number of outputs as you have inputs.
Yeah. Yeah.
Okay.
Okay. Thanks. That's a simple picture.
Yeah. One of the things I noticed in this is these prices. I don't know what a is it yuan? Is that how you pronounce their currency here on the bottom? I don't know how that converts to USD and things like that, or any sort of currency. But it says they are cutting the price down too, and latency is way down. So they're definitely come to play on this.
Yeah, currently it's about 7 yuan is $1.
Okay. So if you go to fourth, that's okay. That's pretty cheap. I didn't do the math too far, but
Yeah.
yeah, yeah. I don't know if this is subsidized by the government or things like that, but I would, it does seem very cheap. I have heard that, just shifting gears here for a minute, from a data center standpoint, I understand that, I mentioned that Jensen Wang said that they could, get them up quickly and things like that. But I also heard in terms of excess power generation capability, they have dramatically larger excess power than the US does. The US is, pretty much everything we have is pretty much used right now. In worst case, we don't have enough, right? But in China, they have something I saw said almost like a 2x generation capacity versus usage. So this does give them a lead in being able to, create a plant, create a facility, and power it without having to build too much additional infrastructure.
Yeah, I haven't dug super deep on it, but yeah, that's my like if I were to put money on who would win an AI infrastructure build out race, it would be China for that reason specifically.
Yeah. I that's what I came to. One of the reasons I like doing these things, doing this thing at the end of the year is because I'm forced to look this stuff up. But yeah, that became very, very clear in several places in this document. All right, let's move on. OpenAI has Sora 2, and things like that. Some of these are probably, that's not that big a deal anymore. But this is kind of interesting that you can integrate real people and their voices and appearance into the footage inside your generated thing. So let's say you were, interviewing somebody or something like that. You could intersperse. Somehow the model is able to intersperse your clip of that in there and then scale it appropriately so it looks like they were, done together at the same time. So that's kind of interesting. Have anybody ever tried Sora? I've not tried it. Okay.
Tried it last year.
And what did you think, Kim?
It wasn't too bad. It was like a holiday video I shared in a demo. They say Sora 2 is a lot better.
Mhm.
And then there's also a new OpenAI, I think within the last week, image model, that competes well with the Nano Banana now.
Oh, okay. Cool. Well, it is, that's why I want to spend a little time on the video stuff, because it seemed like there was a lot of action happening in that space. And, I just know the financials in that business, it's just a money burning business and things like that. So, okay. All right. We're going to move out of that then and talk about having your AI collaborator with us. You can see this one here. DeepMind has this thing called coscience. I've not tried it. It's based on Gemini 2. But it's kind of interesting. My daughter actually does this, develops treatments and works with her company, and then works to her chagrin with the FDA for licensing processes and things like that, talking to their scientists and talking to her team of scientists that she manages about working together on these drug sort of things. And when I showed her this, she got quite excited. She goes, "Really? We could do this? I could get more staff. I could, augment my staff without having to hire a lot of people." I didn't quite understand that, and I will endeavor when she comes by this weekend to ask her a little bit more about that, because I'm trying to figure this out. And but she was quite excited about it. So I don't know. It's one scientist's opinion on it. This is the part I think that kind of excited her, was it's going from, right now in science, they use machine learning, AI, and things like that, just on the fringes mostly. And this actually lets them pull it in to the major roles. So they have like an agent role. PI is something they call principal investigator. That's the person that creates like the theory and things like that. And then they have reviewers and experimenters. Reviewers are the people that kind of review the data and guide maybe what the principal investigators are doing. Say, hey, maybe we should look in this area, or this looks promising, this doesn't look promising. And the experimenters are actually lab people. She doesn't do this, but she has a whole lab staff underneath her, that they're the actual guys that create the tests, run the tests, produce the data, and then feed it back to their senior level managers and scientists, which is what she's part of. And then they, if they could do that with AI, all these agent roles and things like that, her biggest complaint is, well, we sent this over there and it's not coming back, we don't get it back. If the AI could give it back to her in a day when she has to spend time like calling up somebody's boss and go, why isn't your guy done with this? Where is it? Was it we want to file with the FDA, that sort of thing. It would really, really, I understand why she was excited about this when I showed it to her. Okay. Co-scientists, DeepMind has this stuff. And once again, this is drug candidates. That's where I used to work. When I worked for Novartis, we were in the oncology division. And we did blood cancer and things like that, and epigenetic targets for liver problems and things like that. And once again, it was a very, very manual sort of thing, and things got lost between the cracks. If we could make that much better, or the lab, we had like a lab clean out day every year, and every once in a while somebody would, really dig back into these freezers we have. We had guys pulling samples from like 25 years ago out of the freezer. The guy who was the principal investigator on it had died, so none of us had any idea what this stuff was. It could have been, some sort of exotic disease or things like that. But it, having a virtual lab that, that you can work with this stuff, track this stuff and things like that would be really nice. And I guess Stanford has a virtual lab here, is a principal investigator. So in the world of drug discovery and drugs and things like that, the principal investigator is the brain person. This is like the person that gets the Nobel Prize if whatever you're doing is really, really unique, save some stuff and things like that. So that the fact that might be an AI agent in the future, that's sort of groundbreaking for that business.
Yeah, I look at these like more pay tiers. I mean, it's similar to Grok has heavy and Gemini has some $200 a month. And now this DeepMind co-scientist, I haven't seen if they did a Gemini 3.0, but it promises to take care of more things on the science or medical things. I don't know. I haven't heard any positive feedback. Yeah. It's just, I'm sure it's one of those, it's just another pay tier.
Yeah, I don't know. Yeah, I'm trying to think if it's a pay tier or are they piloting it maybe and just piloting it. They wouldn't have, DeepMind has a lot of resources, but I don't think in terms of like drug discovery, and they're talking about like, leukemia and things like that. I don't know that, they have the wherewithal. They'd have to team with somebody like a Stanford or UCSF or one of these big high-end sort of labs and things like that, or research lab and things like that. So I'm not quite sure, where that would go, There
was a recent OpenAI communication. They said we're more than just, our performance is more than just chat. And then so you're not seeing the best of what they have in terms of Chat GPT. And I don't think even API or GPT 5.2 Pro, because there's partnerships and these types of things that they offer some at least longer context or more usage, but maybe even other features too that the general public doesn't see.
Yeah, I'm sure there are, and I like I said, I would think that DeepMind, while they're a very deep, very wide company, they probably have some people in that area, but they probably don't have people that does like create drug candidates and things like that just for a living. That's just not their business. That is somebody else's business. So they would have to team with somebody that did that. Maybe Stanford would be a good target, things like that. Okay. All right. Yeah, and this is let's see. I don't remember. Oh yeah. So you as the human defines what, sets criteria, initial solution, optimized background knowledge and things like that, defines the problem definition. And then this model supposedly figures out, based on trials and drugs and things like that, how do we create a model that would make proposals to improve the program, improve our process and things like that. That's pretty unique, I thought.
I'm actually going over this in my introduction right now.
Mhm.
Before this, they had Alpha Tensor, and this is before LLMs. And then they had another one called Alpha Dev. And then this is kind of like their latest 2025 update to their,
Hmm.
algorithm developments.
Were those successful, Kevin?
I believe so. Yeah, one was like a game.
Mhm.
So both were reinforcement learning to discover new matrix multiplication for one, and then new sorting algorithms that surpass decades old human benchmarks,
Mhm.
basically, through computational advantage,
Okay. Yeah, this
sifting
one
through a
looks.
vast space.
Yeah, this
Yeah.
one looks like it does a lot of mathematics sort of things. Ted probably knows more about that than way more than I do. So, okay. Uh, they have something that's a universal interface model for biology, and I think I got a little ahead of myself on the last one here. Uh, yeah, that it works at at an atom level, representing the interface across proteins, nucleotides. One of the things in drug discovery is we've cured cancer a million times, right? The problem is we kill the patient, or we can't make it in a stable model, and the drug kind of falls apart after very, very short half-life, so it can't get to where it needs to be, things like that. So there's all these millions. This complex interaction diagram brought that to my mind. So we have all these great things that we can do in a test tube, but we can't make it work in a human or an animal or a biologic system that we want it to. So if these things can let us test those and you know try them out and maybe come up with some new based on our experiments, or say, hey, you guys should have looked at this area or something like that, that would be a really huge sort of advantage. They talk about these in let's see, 2,646 previously unannotated ligand-binded sites, and wet lab conditions. Wet labs means you're actually taking. You've probably seen this on TV where they're actually like draw up fluid, put it in a pipette, and then move it between things, or they have a machine that does a similar thing. But it's honest to God, real biochemistry going on versus theoretical stuff. So they're saying they now can report things that represent a biochemical marker signal moving across these various things, which is, from a cancer researcher standpoint, one of the tough things to do. I mean, the thing you want to do with cancer is not kill the patient before the cancer, right? That's kind of one of the basic things. So you have to have a way of seeing how things are going, and that is a difficult thing. So anyway.
Yeah, this could be really tricky because even if you have the best drug on the market, it still
Mhm.
has to go through preclinical,
Oh,
phase
sure.
1, 3, clinical trials, FDA approval, the whole thing. So I think for a startup project, it's more challenging because you don't have the
Mhm.
resources to say have a whole trove of these, and that's why I
Yeah.
focus on clinical trials. I've done 3 simulations, but
Mhm.
yeah, these are trickier because at the end of it, do you have the resources to put it through clinical trials? Where other big companies do, and they probably have a stockpile of candidates just sitting there too.
Yeah, but even then, you know, the one I worked for was one of the biggest in the world. And still, these are multi-million dollar efforts, right? I'm sure you know that these are multi-million dollar efforts. And as you move up the FDA chain from experiment, moving towards a real, viable something you can put on the market and stuff like that, there's a huge winnowing effect, right? We are spending so much money on this, and we had to go back and redo this. Are we ever going to make back our investment? I mean, it's a tough business and things like that. So I think they have to do that. And if they can do that, if they can do anything to reduce the number of dead ends they walk down, that's good for them financially. It's also good for us, the end users of these products, because we get potentially more better projects sooner. Okay. All right. Let's see here. Language models and chemistry. Chemistry is a weird thing. I never liked it, even though I was majoring in it for a while. I never really liked it, especially when we went to organic chemistry. I really liked non-organic. So, if
Well, I'll
you've,
tell you a story here is
yeah,
I've taught organic chemistry, but I knew somebody that worked at one of the leading LLMs and he was a trainer to train on
uh-huh,
chemistry. And he wanted to keep scaling things up like multi-step synthesis and they just said no. And it's just not as much of a priority as medical is, closer to the
mhm,
patient with
yeah,
diagnostics and clinical trials and these types of things. And same thing, I think, with a lot of drug discovery too, on the molecular basis, not as much as opposed to like wanting the cure to cancer and training more towards the high money areas as opposed to chemistry, where it just hasn't seen as much in
mhm.
iterations.
Interesting insight. That's an interesting insight. I think I wonder if you could reduce the costs, by 2 orders of magnitude, would you be able to do more experimentation? Because I've seen numerous things look good, look good, look good, and they said, no, 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 it's just going to cost us too much. We're just killing that project type thing. I'm sure you may have seen that too.
I haven't seen, the NVIDIA is really big into bio, with
Mhm,
the molecular docking with LLMs and having the English interface, but I haven't seen anything like this because again, it's more theoretical and
mhm,
if you're aiming for a drug, this is the most fundamental level that's not typically well funded and trained on.
mhm. Yeah. Well, that's what I wonder though. If you could do it in silicon instead of, in the wet lab or things like that, what orders of magnitude in terms of cost reduction would you get?
Yeah,
You
there
know?
the closest thing I have for this, there's a paper called CROW. I presented
Hmm.
on this a long time ago, and they wanted to do that same exact thing, use LLMs to screen drugs, and then actually have it automated on a reactor to produce the
Ah.
drug in a line. And some things work better than others. This is like GPT-4 era, and they had to use GPT-4 for everything for it. But there is some innovation with it. But again, maybe 2026, somebody will come up with something like that.
Well, hopefully it's not one of these things, right, where next year we'll get to it, and then next year it's like next year, you know,
I
sort
think
of thing.
a lot of people in science, period, like chemistry and other fields too, and physics, they use ChatGPT and others a lot, but
Mm,
there's just so far you can go with it in terms of, say, I use it for directly R&D, where these
mhm,
other fields they have to stop, like they can't use it for intense R&D for chemistry, uh, maybe more so physics, but it just depends on what they're doing too.
mhm.
There are benchmarks that now that I think of it on chemistry and physics is usually the highest out of that in medicine and chemistry.
Okay. Well, hopefully, our models, or not our models, but the AI models can, help us move beyond some of the restrictions we live in now. Okay. And I stopped here. Why did I put that there? Never mind. Uh, AlphaFold 3, that's the protein folding, right? That's like Nobel's type stuff and things like that. That's gone on. Because if we understand how to do that, we can understand how to store these things, deliver them as drugs and things like that. So I just put this in there just because I could. I'm just going to move on from that. There are also things that are being used in the diagnostic world. Uh, there are models that it says beat unassisted doctors on various diagnostics. I don't know what an NEJM grade diagnostic is. It's probably some sort of standard thing. And outperforms primary care physicians in simulated consults and things like that, which would be good, especially in the United States, given this, our abominable healthcare situation that we do, and things like that. Not so much in other regions and things like that, but the U.S. is personal. That's a personal thing for me. It's just not very, very good with its healthcare relative to the expense spent.
Jerry?
Yes, Alfonso, I can barely hear you.
Sorry. I believe NEJM is the New England Journal of Medicine.
Thank you. So that's kind of the gold standard, right? If I remember right, about as much as medicine as I understand.
Yeah, that's up there. That and Lancet.
Yeah, yeah. So if you are getting published in there, you must know your stuff, I assume.
And it's been well reviewed, typically.
Oh, okay. They don't just it's not like we are in the AI world where it just came out yesterday. Let's get it up in, in a journal or something like that.
Yeah, you publish it on an archive and you're good to go.
Yeah, yeah. Yeah, we work in a little bit different cycle, right? But that's good to know because, yeah, the New England Journal of Medicine, I remember when I worked at it was Novartis was a drug company I worked at. We had stacks of those and things like that because, even getting the damn journal, the physical thing is quite an expensive deal. I'm trying to remember what it was, but it was quite an expensive thing to buy a subscription to. So, and this is, 20 years ago, so we were reading real paper. Okay. Anyway, one thing to note here is that clinicians do better when they're just when they get these tools in these tests in terms of accuracy of making diagnoses and things like that. So there is an advantage to using these tests. So I would not be surprised if, you start seeing more of these tools come out and it's like, given that the patient has these symptoms and these metrics and things like that, have you checked for this? Have you checked for that? And things like that. And, because this is talking about a clinical model, that's like us going to the hospital type thing. And it's if it can increase the accuracy of those clinicians in diagnosing us, I'm all for that, right? I'm sure we're all for that. So.
Yeah, I think worst case scenarios like a breakthrough device, if somebody's on their deathbed and they say, hey, we need to talk to the computer really fast, I could see an FDA breakthrough designation for that case. But I think many cases it'll be code how it is today and not using LLMs, especially online. And given all the explainability issues too, that it will just be generating code faster with LLMs.
You're probably right. I mean, medical systems are not bleeding edge technology. You know what I mean?
Yeah, just replace the code, with how LLMs make it, validate it, and that's how I see things.
Yeah, you're probably right. It has to fit in because the medical establishment has been there for decades and hundreds of years, literally, and it's like a big battleship. It doesn't turn real quick, right? So.
Yeah, the term that we use is non-decision making cases is how people will continue to use LLMs. But I think especially like on a routine basis every day and for drug discovery and all the way up to clinical trials, it's going to have to be code, but now LLM generated code.
I see. But who validates the LLM generated code though as being accurate? I guess the person who ships it.
I would assume use the same methods, but I think that you might have to use more. I don't know, if that would be a requirement that everybody says we need LLM specific validation of code. That's still yet to be seen. But I think on the basis is you have the code and then, validate it using existing techniques, just like how we would question a human, how they design the code, but we care more about the finished product.
Right.
And not so much carrying back into the LLM, but we have the code instead of the human created it.
Okay. Yeah, I could see that. You don't want, these are people's lives you're kind of messing with, right? So you want to be, a little slower maybe on that. So, okay. Thanks, Kevin. Okay, let's take a look at some tools and trends. This should come as nothing, earth-shattering to this group. We've got a lot of AI agent frameworks, right? And we're starting to see, I think the thing we're seeing is that a lot of them did the same thing originally, but now we're starting to see them move more towards industry specific or application specific sort of things. So here's this one. Let's see. Yeah, they have agents to do structured development workflows. Bleh. Let's see. Research first framework to declarative program synthesis and pipelines. But just moving it to various things where we may have depended on like the senior lead or something like that to kind of lay this out before they launched, and maybe these tools will replace some of that. Are you guys using any of these tools to kind of lay out? How far are you letting AI and things like that lay out your code and what have you not?
No,
All the way?
I'll mention that I've tried all of these except Agentverse, I believe. Although I've heard of Agentverse, I might actually use that for some user research at some point. For me, AI writes all my code, but it always has. So,
yeah. What do you think of the quality of these tools today?
This set of tools particularly? Or?
Well, just in general of the tools that you use. I mean,
well, I think largely in terms of doing. So like these are tools that I might reach for if what I wanted to do was like you I guess tell my AIs to build an AI agent product that I'm going to go serve to somebody else, right? Like that's what I would not use these, or I might use these if I needed to like build myself a custom tool or whatever. But in terms of me like using it picking a tool that I am going to use in order to generate code for myself, that I generally reach for tools like Claude Code and Cursor and stuff like that instead.
Is that just because of familiarity, or is it a better tool?
Yeah, I don't think these tools are designed to do code generation. They're like they or like so to I guess to like quickly go one by one. LangChain is used to be like bloaty and annoying, but is now good for. It used to be prototypes only, but Harrison's been working on it a lot, so it's I might occasionally use it if I was doing something probably in Python. AutoGen is actually not a thing anymore. Camel is a very cool research kind of project that's like a multi-agent sim kind of thing. It's pretty cool. Camel I would use for like simulated user research. AutoGen is another like kind of like agent studio thing, if you will. MetaGPT was like kind of an experiment, more or less. It was one of those. It's like Baby AGI, if you ever heard of that one. DSPy I have tried to use, but and I suspect there's power in there, but the learning curve thus far has been too steep for me to find it useful. I want to like DSPy. Out of all of these, the one I want most to like is DSPy. Llama Index is useful, but RAG is not these days. Agentverse is also potentially user research, but I don't know that one. LangGraph is like multi-agent systems. I have used it a couple of times. I didn't find it very intuitive. Letta and MemGPT, I actually am a big fan of that team, so I probably will, if I am looking for something that is like specifically a memory solution, I might reach for that. As like an external source to kind of wire up any agent that I'm using to sort of like have a portable memory system, maybe that's like a possible use case. But for the most part, for memory, how I approach that is I build memory into my code base. My code base should remember for my agent essentially. And then yeah, those are a lot of those are like the smaller guys or like yeah, the little lightweight frameworks are usually just like interesting to play with. I find frameworks that I've found the time that I reach for a like a agent framework is if it's like lightweight but opinionated in the correct way if the team has correct opinions for the use case that I'm trying to go off. And then usually, especially if I'm like sticking to TypeScript, that's when like frameworks like Mostra and stuff, it's nice because they've already figured out all the networking stuff. They're just like, here, define agent stuff. And then anything your agent wants to go like touch or do on the internet, we've already figured all that weird stuff out for you. So that's usually what I use it.
Cool.
Yeah, and I've used a couple of these too, LangChain, LangGraph. I feel with this, it's like the perfect is the enemy of the good. And the whole point of LLMs is you could use them quickly and you don't get caught up. And then you can switch to different LLMs right away. If you get too involved with your workflow, it becomes too complex. You've missed the point of solving big problems, which take a lot of steps to do, even with LLMs. They're not unlimited. So
Right.
yeah, I think some people use them, but I I think the whole trend with making, agents with small LLMs to reduce complexity, to try to get consistent performance isn't necessarily experienced by everybody.
Okay.
Yeah, and
All
I
right,
think the Jerry, the thing to understand about this slide is we're really talking about any kind of compound system. So it could be as simple as you just want to do RAG,
mhm.
okay? How are you going to basically embed and compare embeddings with your database? You could write code to do that, or it's like, hey, guess what? There's most of this already built into LangChain in Llama Index, right? Um, if you wanted to do, so we don't have all of these things today, but if you wanted to do something and just put it on your phone, and so you want like speech to text pipeline into your LLM, it will be
Mhm.
really nice to have a future version of something, LangGraph, that just has that feature so you don't have to write any of that code,
Mhm.
right? So this isn't necessarily about any one particular use case, but yeah, I think somebody said it warrants it. If you're building an application, you know, um, for really basic stuff, you can just use, Gemini, right? I can upload an image and boom, whatever. But if I'm doing anything that's a compound system, so the compound system could just be stuff like RAG, or it could be agentic stuff where you have multiple LLMs and you have, tool calling or whatever. But I think this area is going to continue to grow, and then eventually we'll see consolidation of the winners, right? So if Warren
Mhm.
says, everybody's starting to like hate, whatever LangChain for this and MGPTs,
It was cool to hate on
then market share will just go there, and then the number of players will,
it.
reduce. But right now, I think there's just too many different problems people are trying to solve. DSPy is where I would go for optimizing my prompt, which is not really what you use LangChain for at all. And so I
Mhm.
think that's why you still see this proliferation. But eventually we'll get wide feature sets in all of them, and then I
Do,
think the winners will
do, you- do
consolidate.
you think do you guys think we'll converge down then? I mean, this is a lot of products, right?
Yeah, so I think, or at least for me, in terms of, I think kind of Ted describes kind of the sort of your average, here's a thing to do in open source. Now open source is going to make a bunch of frameworks of how to do it. And like some of them will be dumb and suck. And then others will be like, hey, this is useful and saves me a lot of time. So I'm going to use that one. I think the like confounding factor in current year for open source and just like languages in which you can install packages like Python and TypeScript. Considering that we get like a usually at least somewhat significant increase in model coding capability every 30, 60, 90 days effectively. Like somebody's trying to beat somebody every that amount of time. I think it's difficult, like unless you've specifically accounted for it as a framework, what your job is as the framework changes really, really fast. So you have to be set up to adapt to new capabilities. And then there's all the sort of secondary cases like, is it faster for me to install, learn the quirks of and debug this thing that is claiming to make it easier? Or if I just tell Claude and GPT 5.2 to like make me basically this same thing, and like watch them do it, am I able to operationalize faster and or better?
Yeah, and this made sense when model releases were every like 6 months or a year. The whole thing with LangChain and LangGraph, as I'd use these Python demos, is GPT-4 was not good, and it was an effort to fix the model. So now the models are released all the time. So I don't think the need is as much as it was in the past, where they thought they could just have like a silver bullet, and then you'd have a better GPT-4 because not many models came out during that time anyway.
Yeah, I would say
But
model
I don't
capabilities.
completely agree with that sentiment because let's say you just want to use the latest, and so I'm switching from GPT 5.1 to 5.2. I still need some framework if I'm going to do RAG.
I mean, unless GPT 5.2 is good enough where you can go, hey, GPT, like here's a big, I have a bunch of documents in this folder. I need like a RAG pipeline that works with my DB. Here's the link to my DB. Like check it, fix it. And it does. So like once we hit that point, you don't really need RAG frameworks anymore because you can just magic one up whenever you need. Unless the RAG framework is like by somebody who is incredibly good at RAG and made a bunch of very good decisions and has very good opinions about it, in which case 5.2 might not be able to encapsulate the like full philosophy of a given framework. But if you just need like a random thing to do RAG for you, it's probably faster to just tell GPT to make you one than it is to like go on NPM and look for which one you want, right?
All right. I don't think we want to go down the rabbit hole here. I personally disagree. I think that you're better off having the latest good coding agent write the code and config whatever type stuff to actually use a really good framework, like let's say, LangGraph, rather than having it code all of that in just vanilla Python.
I totally agree.
Right.
By the way.
Right.
Yeah.
So yes, I'm not against having the LLM write the code for you, but it's still going to have to write 100 lines for LangGraph, whereas have to write 2,000 lines of just native Python, and then you might have bugs that the LangGraph people have already debugged from the previous 1,000 users.
Yeah, I think that's the thing is if you're doing something like really complex, like you want to do non-blocking async agent coordination with caching of messages in a bus, like there are like 30 problems there that are going to be an absolute pain to figure out. So if somebody else has already figured that out for you, just use that. But there are a lot of frameworks that really didn't need to be, or frameworks that are like arguably entirely surplus that I think the other thing that I've run into with these is if a framework is really good and really new and you want to use it, it's not in your model's training data. So your model is going to suck at using it. Your model likes LangChain because it's very popular and lots of people talk about it on Twitter, but it only remembers a particular version of LangChain. So it will write. You can tell the model to use a framework, but unless that framework is like an evergreen one that's been around for a long time and is very present in the training data, and all those patterns that are present are still ones the framework uses, it's not going to be productive to get your model to use that. It'll be better for you to have a model that generates it for you and has it generating it in its context currently, so it knows how it works.
Yeah, fair points. And I think that's why this slide is saying that the ecosystem is right now still kind of chaotic.
Oh yeah, super chaotic for a while.
Right. I think. But like for example, I see VLM potentially on the inference side just basically like eating up everybody else potentially.
Mm-hmm.
And again, like maybe you're doing something very complicated, but I think you're still better off doing a couple PRs on VLM versus just saying I'm gonna write it from scratch.
I will also agree. Do not rewrite VLM from scratch. Yeah.
Okay.
One additional benefit of using a framework is that it provides some additional functionalities, like the land graph and the land chain. They also they have also a product called Landsmith.
I love that. Yeah.
Yeah, you can like trace your agent, monitor it. Yeah, but so if you would do that in plain code, it would be a lot of trouble.
Very
Yeah.
true.
Yeah. And then like anything, right? The more code you handcraft and right, the more you have to maintain.
Yeah, it's like, is it worth maintaining this? Is there a SaaS that does it better? Is there a opinionated framework with good opinions that does it better? Or is it faster for me to just like jank something together with GPT real quick is kind of
yeah. And I think, if we go back to, just regular programming, we were writing C++ or C or something like that. And, we built up, we had all these libraries and things. And that's the reason we did all that is so we didn't have to do busy work and things like that, if you will, or the things
I see
that
a lot of
everybody had to do.
people having to do end-to-end comprehensive studies, what their boss would have had to tell them to do, and to be able to use it, whatever service you're doing quickly. Because I think that's the misnomer. People think about LLMs that it's a single answer, but it's really a lot. It's a sequence of steps. And it was like this before AI too. But everything requires many steps, and it's using the most efficient workflow to get it done fast. I just had 2 studies. They were like 12 days publish, 14 days publish, and that's sufficient, right? So that's a thing to think about. Are you able to get your output by a certain time, knowing that that specific prompt, that single task is not the only one that you're going to have to do?
Yeah, I think the reaching for a framework is if all it does is save you busy work or boilerplate, we have a different machine for that now. We don't need that framework. But if it has has solved hard problems that would take a long time for you to figure out how they ought to be solved, then it does that in an effective way or provides like platform external benefits, et cetera, then I think it's worth consideration.
Okay. I'm going to move us on. All right. But of course, now that we have all these tools and things like that, we're kind of repeating what we just did here. We have a whole bunch of research papers and things coming out, on all this, and this is the best way to do this on like tools, planning, because we're starting to develop a new way of doing things. And it sounds like a number of you are way, way out ahead of, I think, the general crowd on that. This chart over here is interesting on just the counts of research papers being dumped out into these areas. Ted, do you remember what the number was for NeurIPS this year? Paper-wise, I remember seeing some
26,000 submissions and 5,600 accepted in the main track.
In the main track alone.
Yeah. There's another whatever 600-700 when you include things like workshop and affinity posters and things like that.
Got it. Yeah, it's if you went back to what were the numbers like 5 years ago or something like that? They're an order of magnitude smaller, or
yeah, it's exponential growth.
Exponential growth. Okay. Yeah, I kind of thought that. I know you attended. I've never attended, been fortunate enough to attend, but yeah. All right. So anyway, we are seeing I guess the number of subjects, what I liked on this slide, tools, okay, we got that. Planning, task, accommodated memory. Yeah. But, if you start reading down these things, it's getting to, what I'll say, broader usage of these terms, things like that. For example, multi-agent system, adaptive simulations. That's not something, at least I thought of, along, 4 or 5 years ago and things. Maybe other people did. But it just seems like it's expanding. This list of things, moving ideas into production, is not only expanding vertically, but also in the breadth. So, which is really kind of a cool thing. So hopefully all of us will stay employed, for a while. Things like that. Let's see, do we have anything else? Oh, yeah. One of the other things, and I think we're at time now, so this will be our last slide. Agent memory is shifting from ad hoc context to structured persistent states. We're now state tracking and things like that. I don't know which particular frameworks do this. If you guys do, please chime in. But this seems like the right thing to do, right? That we would want to have long-term storage alongside short-term context just for keeping ourselves on track and things like that. Okay. All right. Oh, this gets to the NeurIPS thing that we were talking about here. A prolific author has 5+ papers accepted at a given conference is also on the rise. So somebody that just spends a lot of time, I guess, producing papers and things like that. I heard this before too, that NeurIPS has allegedly demanded reviewers reject 400 papers, 400 to 500 papers originally recommended for acceptance. And I think I assume that was done for scaling. Does anybody know that it was just getting out of hand type thing?
Well, I can tell you that NeurIPS claims that they did not do this. You can debate whatever. It was in San Diego this year, and I can tell you that San Diego Convention Center is large enough that they could have easily had poster sessions that were 20, 30, 50% bigger, and it would not have been a floor space limitation.
Okay.
So whether or not they wanted that many is one thing, but they were not constrained this year. Whether next year the Sydney Convention Center is big, I don't know, but at least this year that is a plausible argument that they made that they were not space constrained.
Okay. Yeah, it just seems like, I was looking online, and the number of complaints from some reviewers about, oh my God, they want me to review, 5 papers in, I don't know, 3 days or 4 days or something like that. I saw a number of things like that seemed like there was an overwhelming amount of work to be done. But maybe it's just, I happen to pick the guys that complain a lot. Could be.
The problem with all this is the LLM generated context is huge, and people think that you could still use human methods to review it. And everything's going to shift, in my opinion, inside the paper. So you do AI peer review as you go along, avoiding like an endpoint and then having to reach out to somebody, which will also keep the quality quite high, because you're not having to like stop and then ask people and then but as far as reviewers, there's no way that they can keep up with papers now, because like I said, you can generate a whole section in a paper and get your research out quicker too. So I think they'll switch over, and they'll probably have their own standard ways of doing human peer review too, but it'll be with AI. But the biggest benefit is for the researcher, because you can iterate and you don't have to stop, and you can make much things bigger and check with other AI models too. It's effective technique.
Cool. And I want to point out. Oh, go ahead.
I wonder if, in order to help scale this thing, if the 2028 conference, we people who are submitting more than 5 papers could just submit a prompt instead, and then have the AI just generate all the articles, design the experiments, perform the experiments, gather the results, and publish those, and then have AI review that as well.
Yeah, somebody did that recently, actually.
I do it every month. I create experiments. I get my whole project set by AI, run the experiments, validate it with other AI. It's happening now, 2025.
Cool. Yeah, this diagram in the lower right was kind of interesting, but then I realized it's fairly behind the times. There's no 2024 sort of things. But I think the trend is clear, right? These conferences are getting more and more things, and they're having to play games and things like that to keep track of them and to still do a good job, because these are the leading sort of conferences that are supposed to show the state of the art in AI type things. So whatever. Okay, where are we at? Oh, okay, we're at a good stopping point. Yes. We're up to section 2 of 5. We're not doing 3 and 4. But anyway, we'll stop here then. We'll talk.